Now we are going to discuss about Fourier series analysis of continuous time signal, in particular problem discussion. This problem, we need to find out Fourier series coefficient for a given waveform. So I'll just read the problem statement. Determine Fourier series coefficient of periodic signal x of t with fundamental period capital T given below. You can see this figure. So this is the periodic pulse train, and period of this particular pulse train is capital T. In particular, I can say that the pulse is defined over a small duration, that is minus t12 plus t1, and the same pulse will repeat over each and every period. And here this is a periodic signal, so graphical representation is given. We need to first find the mathematical expression for this particular pulse. Already told you that periodic signal will repeat over each and every time period. The same waveform will repeat over each and every time period. So first we are going to write the mathematical expression for this particular signal. So the mathematical expression is given here. So this signal is defined over small duration, that is minus t1 to plus t1, and the amplitude of the signal is 1. Amplitude of this signal is 1, and rest of the thing is 0, that is minus t by 2 to capital T1 minus capital T1, and T1 to capital T by 2, that is these two places the waveform value is 0, and this duration the waveform value is 1. So the expression, mathematical expression, is written like x of t is equal to 1 when magnitude of t, small t, is less than t1, capital T1, and 0 to over the duration, that is t1 less than magnitude of t is less than t by 2. That is, so I have given this magnitude of t because the signal is defined over positive side and negative side. So magnitude of t represent both positive and negative. Because of that I have given this magnitude of t. So this is the mathematical expression for the given waveform. Now we are going to find out Fourier series coefficient for this particular waveform. So Fourier series coefficient formula is given here. A suffix k is equal to 1 by t, capital T, over integration over capital T x of t into e power minus j k omega naught t into dt. Okay, we are going to substitute omega naught in this equation. Omega naught is equal to 2 pi by t. Just substitute and you will get this equation. Now we are going to find out Fourier series coefficient for two different cases. One is k is equal to 0 and k is not is equal to 0. When you are substituting k is equal to 0 in this equation, you will get this particular equation reduced to a naught is equal to 1 by t integration over minus t12 plus t1 dt. Okay, so when you are integrating this particular integration dt is equal to t, and you have to substitute upper limit and lower limit. This is upper limit and lower limit is minus 1. When you are substituting, you will get 2t1 by t. So this is nothing but a naught, the first coefficient, and when k is not is equal to 0, you will get ak is equal to 1 by capital T integration over minus t1 to plus t1 e power minus j k omega naught t into dt. So when you are integrating this particular equation, you will get this one, that is 1 by capital T. So when you are integrating e power j k omega naught, you will get the same thing divided by the constant part, that is this one, that is k minus j k omega naught. So e power j e power minus j k omega naught t divided by minus j k omega naught t and upper and lower limit. So when you are substituting upper and lower limit, you will get this equation. Okay, so the constant part I have taken outside, that is 1 by j k omega naught t in the upper limit and lower limit. When you are combining these two terms using Euler's theorem, you will get, so here actually you have to multiply 2j in the denominator and numerator. When you are doing that, you will get 2 into sine k omega naught t1 by k omega naught t. Okay, now this equation reduced to this one because omega naught is equal to 2 pi. Omega naught is equal to 2 pi by t. When you are substituting this in this equation, 2 this 2 and this t will be cancelled out. You will get k into pi. So the final equation is sine k 2 pi by capital T into small t by k pi. Here k is not is equal to 0. Here you have to substitute different values to this k except k is equal to 0, and we have to find out the value of Fourier series coefficient. We'll start with assuming capital T is equal to 4t1. When we are substituting k, capital T is equal to 4t1 in AK equation, what will happen is this equation will reduce to reduce to sine k pi by 2 by k pi. So actually sine pi by 2 is 1. When you are giving different values to this k, you'll get 1 minus 1, 1 minus 1, something like that. Okay, for example, you take this figure. So when k is equal to 0, already we have determined a naught to capital T1 by t, capital T, and when we are substituting k is equal to 1, k is equal to 1, you will get this term, sine term will become 1 by pi, 1 by pi, and when you are substituting k is equal to minus 1, again 1 by pi. When you are substituting k is equal to 2, sine pi will come, so sine pi is 0, sine pi is 0. When you are substituting minus 2, k is equal to minus 2, again sine minus pi, that is again 0. When k is equal to 3, you will get 3 pi by 2, sine 3 pi by 2. So sine 3 pi by 2 value is minus 1. Hence you are getting this coefficient, and so on. It will go like this, left hand side and right hand side. So that is minus infinity to plus infinity. This is the waveform for Fourier series coefficient when t is equal to 4t1. Okay, so at the same time you can even assume like this: t1 is equal to 1 and t is equal to 4 also. If you are doing that also, you can even draw it. Okay, now we are going to substitute t is equal to 8t1. 8t1 in the Fourier series equation, you will get a suffix k is equal to sine k pi by 4 by k pi. You see this? See this? So we have to substitute k is equal to different values in this equation except k is equal to 0, and you have to plot it. So you have to substitute k is equal to 1, 2, 3, 4, and also k is equal to minus 1, minus 2, minus 3, and you have to find out the value of ak and plot it. When you are doing that, you will get this graph. Just see this. You see this. So when k is in between -4 to +4, the coefficient value is positive, and subsequently when you are increasing the value of k, the waveform, that is coefficient value, become negative and positive, etc., etc., etc. Okay, it's something like a sine waveform. And also, of course, when you are seeing previous waveform and this waveform, the coefficient, number of coefficient is increased. And if you are further increasing the value of capital T, you'll get a waveform like this. So further number of coefficient will increase, the concentration will increase. And if you are increasing like that, the concentration of the coefficient will get increased. And finally, the waveform looks like a sine waveform. Okay, so you'll get a waveform like this. So this is the final waveform of Fourier coefficient. Simply we can write this equation like, that is when we are considering t is equal to 4t, so we can write like t into ak is equal to t into sine k pi by 2 by k pi, and we can simply write this equation like 1 by 2 t sin of k by 2. So approximately we can write like this, sin of k by 2. And for the case of t is equal to 8t1, you can write the final equation like 1 by 4 t into sin of k by 4. Here k by 2 and this k by 4, and value of t is equal to 8t, the value will increase. So this is the case for t is equal to 16 t1. T is equal to 16 t1. When you are substituting t is equal to 16 t1, you will get t into ak is equal to 1 by 8 t into sin of k by 8. Okay, thank you very much.